When the specification for JavaScript is drafted, it's called ECMAScript. ECMAScript does not sound as exciting as JavaScript to many people, and that's why we often call it JavaScript. Some of the features are loose typing of variables. So, in contrast to your strictly typed languages like your C-based languages or Java, you can have a variable that has string in it one moment, reassigned with an int in it the next moment, right? So there's no strict typing of your variable. No such thing as a class. This is one of those weird things in JavaScript that you just have to understand. There's no class. When you make an object, you don't do it from a class. You do it from a prototype, which means you take an existing object and you use that existing object and essentially make a clone of it to get a new object. So any object is really its own class from which other objects can be made. There has been added recently the class keyword in JavaScript. It's syntactic sugar, meaning it's just a nice little cute thing you can write, but behind the scenes, you're getting prototypical inheritance, not class-based inheritance. There are all kinds of weird words that JavaScript people will use, like hoisting, closures, destructuring, and unpacking, just a few of the terms that JavaScript programmers like to talk about. We'll discuss a few of these that you need to know. Many of these you don't even need to know to really use it. One of the confusing things is also that there are two different equality operators where you're comparing two values. There's the double equals and the triple equals, which you don't have in most other languages, so you may not have seen that before. At least 5 different ways you can define a function. That might be a bit confusing. I think there are more. I think there's more like 7 if you really counted all the different variations. Well, you'll look at some code, you'll have no idea what it is, and you'll realize, oh, it's a function definition. It's not clear at all if you're coming from other languages. But they all follow the same idea of a function that you know from other languages. There's really not much new in JavaScript. There are a few new things, but not much. There are at least a few ways to make an object. As I mentioned, you can take an existing object and make a clone of it. You can use the class keyword to pretend like there are classes. They allow you to do that now, but really there aren't. And other ways to make objects as well. There are 2 very different use cases for why somebody uses JavaScript. And this is one of the more confusing things to people who have already learned some JavaScript. The web browser understands 3 different things: HTML, CSS, and JavaScript. But only some of the things that JavaScript can do are possible in the web browser. That is very different. The kind of JavaScript code you write when you're dealing with a web page is almost entirely focused on like a user clicking on something and you do something in response to the user clicking on a button, or a user mouses over a picture of a donkey and you replace it with a cat. So visual interactive behaviors, these are the things that JavaScript in the web browser is primarily focused on. JavaScript on the server that handles very different kinds of things. It's okay, a browser has made a request for a home page. What do we have to do on the server side to load up the right content from the database and put it into an HTML template and shoot it back to the browser? That's not about like the user clicked on a button and we want to shift the donkey to be a cat. It's, what do we want to load from a database? Is the user logged in? If they are, we show them this thing. If they're not, we show them this other thing. There are, just business logic tasks that have to be handled on the back end, which aren't visible to the user, the decisions that are being made on the back end. Those are the things we handle in Express and Node on the back end. So they're very different kinds of programming, even though they're both in JavaScript. Browser-based interactive behaviors with button clicks and mouse over events, and server-side routing, loading things from databases, filling in HTML templates, and making sure what's sent back to the browser is understandable by the browser. There are various ways to handle asynchronous events. So what we mean by that are events that don't happen at the same time. In synchronicity, they happen asynchronously. You might have a need for asynchronous events because, for example, if your code is making a request to a database, you're writing JavaScript code, you shoot a request to a database, hey, load up the latest articles on today's news from our database. The database might take some time to respond. Do you want your app to just freeze while it's waiting for the database to respond? Probably not. Sometimes a database might be busy with other things and take a fraction of a second to get the data you want back to you. You don't want your app to just be frozen for that period. So there's a need for an asynchronous event system, which JavaScript has, which is a request can be shot to another computer or another system like a database, but the code can still keep on churning other instructions while it waits for that other machine to respond. So there'll be an asynchronous response to a request. So JavaScript has this asynchronous capability, which is important for the web or for networked computers where you never know how long it's going to take for a computer on another part of the network to get back to you. And you don't just want to sit there waiting. So you can have lines of code. First line of code could be shoot a request to a database. But even before that comes back with a response, you can continue to the next lines of codes. And whenever that database responds, it will then trigger some function to be run, which will handle the response that came in. But you don't just sit around waiting for that. You move on to other instructions while you're waiting for that to come back. All right, so there are three ways you can declare a variable. The keyword let is for defining a block scoped variable. Const is for defining a constant that is also block scoped. So similar to let, but just a constant, meaning the value cannot be changed. And var is something that you should never use ever. That is an old-fashioned way of declaring a variable. Before let and const existed, var was the original variable declaration word. And that has now essentially changed, but for backwards compatibility reasons, we don't use it unless there's a very, very specific case. Var, don't write that word in your code. That is something that you might learn in a web development class that is no longer relevant to JavaScript today. So here's an example of let, and we'll compare to var. So here's an example setting a variable called it to true, right? So let it be true. It, depending upon whether it's true or false, this is the ternary operator, which you may or may not be familiar with from, I'm not sure which other languages you might have seen it in, but Java can do this these days. This is basically an if statement, right? This is if it is true, we'll set it to false. If it is false, it'll become true. So the ternary operator can be very useful for just doing a very simple if-else statement without having to write out the full if-else stuff. So if this variable has a true, it will be assigned false, otherwise it'll be assigned true. So just flipping the value of it, right? Starts off as true, and then this is a true, so it becomes a false. And I'm throwing in here also what we call template syntax of strings, which is, this is how you print out a message. There's a console log function, and you can supply it a string, double quotes or single quotes. It doesn't matter which quotes you use on the outside. Here I'm using the backtick character, the very top left character of your keyboard, probably. That is how you would use template syntax. And what you can do in template syntax is actually put the name of a variable into this $ curly bracket thing, and it'll insert the value of that variable into this string. So that only works when you have the backtick syntax surrounding your strings. You can insert any variable you want, just make sure it's in curly braces with a $ in front of it. So if you wanted to try this, as I said, you can try this in Visual Studio Code. Just copy that code, go to Visual Studio Code, paste it in, save it into a file. I already have a file set up, so save it into a file. And in Visual Studio Code, if you're not familiar, you have a built-in terminal. So you can go new terminal, or just use the shortcut there, and it'll pop open this little terminal down here. And my file is called first.js. So I can just write, once I have Node.js installed, I can write node first.js to tell it to run that file, and it will tell you the output. So that, again, that's a print statement in JavaScript, and it plugged in the true or the false into this spot right here. Const example, I pulled a little fast one on you here. Let me just pull that one up. All right, so I'm making an array, just use square brackets around your array values, like a list in Python. This is a constant, right? A constant means a variable that cannot change its value. But as you might know from Java and other languages, actually you can change it if it's an array. I can go into that in position 1, which is the 20, of course, and put in a ha. So again, if I save that, go down here, rerun that node command, you see I've replaced the 20 with a ha. Loosely typed, the data types are not strict here. You can have an array with a mix of different data types, much like Python lists can do that as well. So here's the difference between some of these things. So if I had let and I did this code, here is a global scope X. Here is a block scope X. Remember that let is a block scoping variable declaration. What that would mean is that let, if it's declared within a block, which is anything within curly braces, that would be only available in memory within that block, right? So if I'm in the global space printing out X, well, which one do you think is going to be printed out? Well, it's going to be the globally scoped. Outside of any block, the block of the whole program, the global block, will have the X available to it. That's a 5, but only within the local block here would you be able to print out X and get a 10. We've already talked about outputting to the console. So console log is your print statement equivalent. You can use double quotes or single quotes. Remember, they're interchangeable in JavaScript. But if you want to use the template syntax, like we just did earlier, where you have an inserted variable within a string, then you have to use the backtick, right? But otherwise, double quotes, single quotes are fine. You can just use plus signs to concatenate together strings. So this would print out, this is some text, period. For loops, let's just run a quick for loop for a second. There's no behavior difference here from what you might expect from other languages. So just to kind of prove it, just like in Java or many other languages, you'd have the variable declaration, the starting value of your counter, the maximum, the the Boolean expression that must be true in order for this loop to continue iterating, and the change in the value with at the end of every iteration. First loop iteration 1, 2, 3, 4, 5, right? So you have from 1 to 5, incrementing by 1 at the end of every cycle, using template syntax to plug in 1, 2, 3, 4, 5. You can do infinite loops with a for loop. Most people don't do that, but you can make an infinite loop with a for loop. If you just put a Boolean true here, or some expression that always results in a true, the loop will never quit, right? This will quit only when I equals 6, because I less than 6 will not be true in that case. But if you just put a true, meaning always true, the loop will just keep going. I'm not sure why I included that here. You don't really want to do that, but just to show you the mechanics of for loops in terms of JavaScript. There's a nice shorthand way of iterating through the values in an array with a for statement. So let me just do that. If I had an array, let me just make an array called SumArray. Let SumArray equal, I'll just do a couple of numbers, 10, 20, 90. I'm going to loop through each of those and print them out. Value is 0, 1, 2, 3. What I really want to do is SumArray indexed by some value. So that's the way you could do that. You iterate through as many times as there are values in SumArray, and you can use the index to retrieve them. The while loops are just like whatever other language you know. So just to prove it to you, copy this. Start out with I as 1. As long as I is less than 6, we'll print out the value of I. Curly braces, of course, surround your blocks of code, whether they're for loops, while loops, if statements, function definitions. Curly braces are the block identifier. So 1, 2, 3, 4, 5, just like the for loop we had earlier, I'm iterating through the values 1 through 5 and just printing them out. So again, I'm not going to sit on this one because I'm assuming you know while loops, but if not, just go back and check it out later. You can, of course, do infinite loops like any other language. If you put a true there, you would have this loop continue going forever. No matter what your I value is, if you're checking against true, it's always going to keep iterating. The double equals versus the triple equals, I just want to clarify what those are, because you might see example code where you see a comparison with 2, and sometimes a comparison with 3 equal signs. 1 and 1, what's happening here? This will end up being a true. So I'm giving you what the result of these expressions are right here. But why is that a true? Because this is a loosely typed language. JavaScript is not Java or C where you have strict typing. So what's going to happen here is called type coercion. JavaScript will try and figure out the proper conversion to the proper type to make this quality work. So it'll see that you're using a number here, and it'll coerce that, meaning do a automatic type conversion for you, if that's possible, to the type on the left. Same with here, you're comparing a Boolean and a number. By the way, there are no ints and floats and doubles and so on in JavaScript. The data type for numbers is number. So I've got a number here and a Boolean here, and there will be type conversion. This will be automatically converted to a Boolean true. 1 is true and 0 is false. Any positive number, I believe, is true. 0 is false. There are also various kinds of null values. There isn't just one. Undefined and null are both essentially null-like values. Undefined, I think, is there mostly for legacy reasons from earlier versions of JavaScript. But null is, I think, what you'd expect these days if you have an object that doesn't have a value assigned to it. So anyway, so null and undefined, somewhat similar, but of different data types. And so there'll be a type coercion that would tell you true if they're both of this nullish type. Okay, so that's the double equals sign. It would do what you probably would expect it to do, but with this automated type conversion, or what we call coercion. The triple equals, the whole point of it is that it does not do the type coercion. So if you actually wanted a false, if you had a 1 as a number and a 1 as a string, well, then use triple equals to do your comparison. If you didn't want true and 1 to be equated as true, then use triple equals. If you wanted undefined and null to be considered different, use triple equals, right? So this is without the type coercion. And that's the whole purpose of this triple equals existence. Semicolons, don't use them. Stop using them. Get out of the habit. They are optional in JavaScript. I am somebody who learned JavaScript when they were required, and so I've had to retrain myself to get rid of semicolons, but it is possible, I tell you, it is possible to do so, and it's actually much more enjoyable to not have to write semicolons at the end of every statement. So you'll see a lot of example code that has semicolons in it if you look up textbooks and videos and documents and so on. Just don't use them. There's no reason to include a semicolon. Just make each statement on its own line, and you don't have to use semicolons. Let's get into functions. And this is where, if people aren't paying attention in this class, this is where you can go horribly wrong. If there's one thing you need to learn about JavaScript, it's that the syntax for defining functions is not what you are used to in most other languages. This is the easy way to make a function that is very similar to what you're familiar with. You have the keyword function in this case. Again, you don't have typing, so you don't have to type your function return values. So just function, and then the name of the function. We'll see that parameters and arguments go in here if there are any, and then you have the block with the curly braces, and whatever your function does, you put it between the curly braces, right? So do something one is running, and here's how you call your function: name of the function, parentheses, any arguments that your function takes, and it runs that code. And in this case, just prints out do something one is running. Let me just put that into my editor and just prove to you that it will print out do something one is running, because here you're saying to call that function. That function says to print this out, so that's what we'll have. So do something one is running. And this is the normal expected result. If you know some other language, you would look at this and have no trouble understanding what it is, I think. Parameters work exactly as you would expect. In this case, I've got two parameters, x and y. Again, there's no typing. You don't have to put the let keyword here. Don't put the let keyword there. It's just x and y. You have then whatever your function does. In this case, I'm printing out those two variable values using my template syntax. X goes here, y goes there. So it'll say do something two is running with x equals whatever x value is, and y equals whatever y's value is. And I'm going to put hello into x and world into y. Do something two is running with x as hello and y as world. You can have return values like any other language. You have the ability to return something. So if you wanted to, you could have another function do something three that takes in an x and a y, puts together a string in template syntax with the x value here and the y value there, and returns that. So if I print out the returned value of that function call, it would be the string do something three is running with hello as x and world as y. Now here's where you start to get interested. JavaScript supports what are called anonymous functions. Anonymous functions are functions without a name. I could take any function I just previously made, like this one, and just get rid of its name. And that's an anonymous function. So you have the ability to do anonymous functions without a name. You might wonder, why would you ever want to do something like that? But we'll get to that, don't worry. There will be a reason why you would want to do that, and it will be an extremely common thing to do. So here's an example of actually a way you can use an anonymous function. An anonymous function, right? Function with no name, and then curly braces, do something one is running. But I'm actually storing that into a variable. So you have the ability to have variables refer to functions. And that's what I'm doing here. I'm creating a variable with a name that is assigned to point to a function without a name. So really, I'm just slapping on the name in a different way in this case, right? Instead of putting the name here, like you would normally do, and just defining your function like that, which is perfectly fine and works well in JavaScript, you can also do the naming like that. Just name the variable, but have the function itself be anonymous. It's the same end result. You've got a function that is labeled do something one that you can call by running that line of code down there. So that's anonymous functions. That's the big mystery. You can have functions without names, but you usually need still some way to refer to them. So you end up, having some variable or some way to point to those functions. It's not like they're just defined with no name and then gone. You have some way to get to them either by variable declaration that is assigned to point to that anonymous function or some other method. You can have these with parameters as well. So again, I can make an anonymous function. It doesn't have a name, but has two parameters, x and y, like we've seen already. Point to a variable to be assigned to that function, and you can then call that variable name as a function call and pass it the arguments that you need. You can have return values in your anonymous functions. Really, your anonymous functions can do anything your named functions can do. So I'm just proving that to you here by giving you example code. With a return value, you can call that what used to be an anonymous function and expect a returned value. Taking that a step further, we have what are called arrow functions. An arrow function is, in essence, an anonymous function. Let me just show you this part here. This is the function definition. Remember, we used to have the anonymous function definition here with the word function, but no name to it. And here you basically get rid of the word function. In the anonymous function style, it would have been function like that. That's the anonymous, the regular anonymous function style. But with an arrow function, again, you extra step, you get rid of the word function, but you do need this extra kind of pointer to indicate that this is a function definition. So it's the same end result, but it's a slightly different syntax. So you get rid of the extra word function. More typing is more stress on your fingers. We don't like that as programmers. So they've shortened the syntax to cause the least harm to your pristine fingers as possible. Here we have an anonymous function just with a reduced syntax. And you just have to get used to this. This is extraordinarily common in JavaScript. So you're just going to be recognizing when you see this is a function definition. Just so you know, you can pass in parameters in your arrow functions, just like you can in your anonymous functions and in your named functions, just the same way you would always do. And you can have return values in your arrow functions the same as you can in any other function. Okay, so here's an even further reduced syntax. Let me show you this one. And again, it starts to look weird when you're not comfortable with JavaScript, but you are going to get comfortable with JavaScript. Here is an anonymous function definition. Let me just simplify this even further. So if I say const x equals 4, let's just say that. That is a function definition. You see that I usually have curly braces, right? I usually have curly braces around some code when I'm defining a function, but in this case, you're missing those. You can have a singular expression, in this case just 4, but I could do 10 plus 2, whatever the expression is that results in a value, I can put right here. And this is an implied return value. So if I did let's do 4, and I said const y is x as a function call, and then console log y, what you're going to see is 4. Right? So how did that work? Well, this is a function definition that returns 4. So if all you're going to do in your function is return a value, if that's the only line of code you need in a function, then you don't need the curly braces. You can just put the return value right there. So I have an anonymous function with a return 4 statement, and it's called x because I made a variable x that points to that function. I can call x as a function call, store the result in y, and print out that 4 in that way. But again, the key concept here is if you see an arrow function, but you don't see any curly braces around that line of code that comes after the arrow, it's just an implied return. It's not uncommon to have very simple functions with singular return values that don't need any real logic, and this is just a way to do that very quickly. This is not the most common way of doing it. You would probably more likely see, return 4 as the usual way most people would write it, but some people who are comfortable in JavaScript would take the opportunity to just do something like that. If you have a function definition, hello equals message console.log message, okay, and hello. All right, so here's my code. Again, looks a bit weird at first, but remember, there's an arrow. It's a function definition. There's no curly braces, so it's a reduced syntax arrow function. This is being returned. Console log is being returned, but it will nevertheless print to the command line. So I don't really need to return it. I'm just using that because it's a shorter way of writing the code. But really all I wanted to do was this, but instead I'm getting this just because if I do that, I don't need as much code. I can write it like that. So anyway, you'll see people doing things like this. This is a function that's just doing one thing, one line. Sure, the result of that line is getting returned, but that's not even what I'm using it for. So I can now call hello, pass in an argument, hi, how are you? And that will then be printed out in this function. Let's run that. How are you? So there's a further reduction. If all you have is a single variable as a parameter, but you do have a parameter, but just one, you can get rid of the parentheses. That only works with one parameter, and that will be the same thing as what we just saw, just without the parentheses. No difference, but it's again a even further reduction in the syntax here. This is starting to look odd, probably for some of you. Here's just a note. This might throw you off a little bit, but with this shorthand return statement, if the value returned is an object, that object must be encapsulated in parentheses. Here's the deal. So if I did, remember that you can do something like that, which is just return a singular value, right? So if I call hello, it's going to return 4. And if I console log the result of that, it'll be a 4. Let me just make it with a no parameter. All right, so I'm calling hello. Hello has this reduced syntax that just simply returns 4. So it's going to console log 4. We saw that a second ago. If for some reason you wanted to return an object in JavaScript can be defined with curly braces. I can say x is 10, for example. So here's my object with one instance variable x and the value 10. If I do that, it gets confused. Why does it get confused? Because this looks like an anonymous function definition, the curly braces around the block of code of a function. Remember, we can define functions that we want to have done like that, right? The curly braces indicate the block that is the function that is being defined. But if all you're really trying to do is define an object, then you need parentheses around the whole thing. So let me go back to the version I had before. If I put parentheses around this, now it knows it's going to return the result of this expression. Parentheses kind of force it to evaluate this as an expression, as a value, and it will see that this is an object at that point and return that full object. Not think of this as a function definition. The curly braces are no longer going to be considered surrounding curly braces of a function definition. So it's kind of a weird corner case here that you would need to know, because sometimes you do want to return an object written in this syntax. Just remember that curly braces are going to confuse it to make it think it's a function definition. So surround those with parentheses to prevent that. There are further oddities in the world of functions. You can have what are called immediately invoked function expressions. These are not going to be the most common things you'll see, but just so you know, in case you ever do see them. If you wrap a function in parentheses, you get an expression. It's an immediately evaluated value or reference in memory. And you can then call that immediately. So for example, I have a function definition, right? Normally you'd have your function definition and then go and call it. That's what we're doing here. It's going to print out do something or doing something. So I've just got a simple function, prints out doing something. But if that's all I want to do is define a function and then immediately call it, which sometimes you do want to do, there's a simplified syntax again, which is put that in parentheses. That will complete the evaluation of that function, put it in memory with that name, and then, boom, go and call it right away with your open and closing parentheses. That's called an immediately invoked function definition. You can, of course, have parameters and arguments and all that stuff too. So just to prove it to you with the template syntax, x equals whatever is in x, y equals whatever is in y. And if I then pass in hello world, I'm going to get hello passed into x, world passed into y, and this function, which is immediately invoked, will print out hello world. So again, it's a simplified syntax if your goal is define function and immediately call it. Can you do that with arrow functions or anonymous functions? Well, take that away. Of course it works. Can you do that with arrow functions? We'll take that off. Put the arrow in, write out. Yes. So any way of defining a function would work in this style. You surround the function definition with parentheses, and you can immediately invoke it with the arguments that it takes, if it takes any. It's a bit odd, not something I recommend using, but if you happen to see any code with a function definition surrounded by parentheses, well, now you know what's happening. What is happening here? Can anyone tell me what the result of running this code will be? So let me read through it for you. This is a function definition in parentheses, right? The stuff here is a function definition. Happens to be an arrow function definition without parentheses around the parameters, because you don't need them if you only have one parameter, without the curly braces around the block of code, because you don't need it if all you're doing is returning something. This is the parameter message. This is the return value, console log message. We're not using that return value. We're just invoking the function here, passing it doing something. That gets passed into message. That gets printed out. We never use that return value, but it's there. Let's discuss objects. There are various ways, as I mentioned, to make objects. I'll show you just a couple. If you just wanted a simple object that you don't mind throwing together kind of manually, well, this is the way you do it. As we saw a second ago, you can surround in curly braces a bunch of instance properties or even functions, as we'll see. And those are now into an object. So let me just copy that code. Nothing really to do. Let me console log me, and you get the details of that object printed out. If you wanted, let's say, the name, you could say me.name, as you might expect with dot notation from other languages. So this is a way for you to define objects very simply with a dictionary-like syntax if you're a Python person. Methods can be, or even properties or instance variables can be added on after the fact. So let me just show you that. If I do something like this. So here I have the object that I'm intending to make called me. It's got some details about my imaginary personality. And then I am attaching a function to it after the fact, just for fun. I'm saying me.speak. So I'm saying make a new, property of me and set it equal to this anonymous function. You can, of course, put the functions directly into the object. So here's another example where the function is just included in the original definition of the object. And lo and behold, there's yet another way to declare a function. There's no function keyword. It's not an anonymous function, but it is nevertheless a function included, and I don't need that, in the object declaration itself. Fido the Schnauzer says woof. So I've made an object, which I'm labeling Fido, has these properties and this particular method. This method accepts a message, and it says this.name, which of course is Fido. The this.breed, which is Schnauzer, says, and then whatever the message is. Now, we mentioned that objects can be kind of copied by cloning them. So let me make a copy of the me thing. Let me just do that. So if I have me and I make a clone of it, all right, so I've made the me, right? It's got some details about me, the imaginary me anyway, and I have a function I've attached to it. And here I make a copy of it. I can say object create me. That makes a new object based on that original me. It's a clone. I'm calling that robot me. And robot me is robot I'm setting to true. So there's a property in the me that I called is robot, and I made it false originally. But in this particular one, I'm making it true, right? So you can take an existing object. This is called prototypal inheritance. I'm taking an existing object. I'm cloning the thing with all the values that it might have been assigned and functions that might have been defined in it, copying them, and I can then go and tweak it and make it slightly different. So me is robot. I'm going to print out, just for fun, console log me, and then print out if me is robot is true, it'll print out indeed, but me is robot, it is true, so it'll print out indeed. If me is robot wasn't true, it would have printed out is not. So it'll say is indeed a robot. But then for the robot object, I'm saying if me is robot is true, which it is not, it would print out is indeed. So this is a false for the robot. So it'll print out is not. So I'm actually embedding an expression, just again, to show you guys some variation in the code here. I'm embedding expressions in this log statement using this syntax that we use to insert values of expressions into strings. You can use it to insert variable values into strings, or you can use it to insert expression values into strings. So here I'm embedding these expressions within the curly brace template syntax. So either is indeed or is not will be inserted into this string, depending upon whether robot me is robot or not. This is me. Me is robot is false, but robot me is robot is true. So here we're checking me is robot. This is the false one. I'm the human, right? So me is robot is false. So that will put in is not. Robot me is robot is true. So robot me is robot is true. So it'll plug in is indeed. Another way to make an object is to define a function, and a function and an object are really the same thing internally in JavaScript. So here we have a function named dog. So we have a function named dog, and I'm going to make a new dog object. So I can set up a function. I'll call it with a capital like you do in class names in Java or something. So it's got two arguments that you can send into it, into these parameters, name and breed. The name of this dog will be whatever you pass in as the name. The breed will be whatever you pass in as the breed. And there's a bark function, yet another way to define a function, with a this keyword in front of it. You can define an instance function of this object in this style. Takes in a message, prints out this dog's name, its breed, and the message that you are asking it to print. So here I'm making a new dog, and I can use the new keyword. This is very much like, Java or many other languages. You use the new keyword to instantiate, usually from a class, but there are no classes in JavaScript. In this case, there's a function. So I'm making a new instance of a function, which is the same thing as a class, really. And I'm passing in Fido and Schnauzer as the two constructor arguments, if you want to call it that, telling Fido to call its bark function, which will say Fido, the Schnauzer says woof. So another option you can have, using a function like a class to make an object, and you can make an object kind of a way you might be familiar with in this style. You can use the keyword class, but remember that this is not really how JavaScript works. It doesn't really have classes internally. It's syntactic sugar, makes it look more like a familiar language, but it just hides the kind of internal difference in JavaScript. So you can say class dog. You can define a constructor function and terminology you might be familiar with. You can put instance methods the way you might be familiar with, and you can instantiate a dog the way you might be familiar with. So this is trying to replicate what you see in Python or Java. It's trying to be a more familiar way of doing things for people. So that's syntactic sugar. That's a relatively recent addition to the language to make it more comfortable for people coming from other languages. There's nothing crazy about arrays in JavaScript, so I will get to some of the things that are I believe, more interesting. This is the way looping through arrays I mentioned in the beginning. There's another way to loop through arrays. Remember, we used the for loop. the regular for loop to loop through arrays earlier. This is the way that these days that you would normally loop through a for loop that isn't looping through an array. If you have, without the semicolons, of course, if you had a set of numbers, 65, 44, 12, 4, or a set of any values in an array, each array has a forEach function you can use, and you can take the value in each spot. It gets passed automatically into an anonymous function, if you want to define it anonymously, into the parameter variable of a function you define as the argument to the forEach. Let me just step back for a second. So forEach is a function. So forEach is a function that all arrays have. What are you passing to that function? You're passing a function definition. This is a function definition that will be run, that will be called for every value in the array, one by one, right? So 65 gets passed in first, and it prints that out. Then 44 gets passed into n, and it prints that out. Then 12, and so on, right? So this is one of these use cases of anonymous functions, right? You often in JavaScript will be passing a function definition to another function as the argument when you're calling it. This is a nice, useful way of iterating through the values in an array. They all come with this function. Any array has this function. You can call it, give it a function to run on each of the values, and it will run that function on each of the values. Another useful function, this is a kind of an unusual one perhaps compared to other languages. You can do a mapping, which would be, you could have an array, and arrays have a map function that is built into them. So we're going to use the map function. And again, you pass it a function definition of some permutation to make on each of the values in the array. So for every value in this array, this function will be called. What does this function do? Takes, let's say 65 the first time, multiplies it by 10, and returns, because that's a return statement right here, without the word return. Remember, if you have a function definition with no curly braces, that's a return statement. So it takes the 65 and returns that times 10, 650. Then goes to the 44, returns 440. Then goes to 12, returns 120. Then takes the 4, returns 40. Those are all going to be stored in this new numbers variable, which is going to be a new array based on the original. So this is a way of doing a mapping from an original array, values in an original array, and some permutation you're doing on each of those values that get stored in a new array. I skipped some of the slides earlier about arrays, to look at the basic stuff of arrays, but you can push new values to arrays. I think I did that here. So using the push function, you can add in additional values. So that it's much like a Python list or something like that. All right, so the map function is kind of interesting. The filter function, I think, is also interesting. I can take the fruits array. So I'm just using a split function that exists for strings, which almost every language has, splitting by comma. So all these commas will be chopped off, and this will be sliced up into an array with avocado, tomato, and banana as strings in an array. There's a filter function, which takes 3 arguments. The value, for each of the values in this array, it will pass the value. So it's avocado the first time, tomato the second time, banana the third time. The index position at which that value occurs in the array, 0, then 1, then 2, and the entire array if you need access to it for some reason. So you have these 3 arguments getting passed into this filter function. For every one value in the array, it calls this function, passes these 3 things. And you can filter, meaning you can return true or false, whether or not to include that value in a new array you're making. So I'm saying return value not banana. So as long as the value is not banana, we're going to get it included in this array that we're redefining as fruits. Avocado passes mustard. It's not banana. So that'll be included in our new array. Tomato is not banana, so that will be included in our new array. But banana is banana, so that will not be included in our new array because this is a false. So if you return true in the filter function, it adds on the value to a new array. If you return false, it does not. So it's a way for you to kind of quickly scan through the elements in an array and decide if you want to keep them into a new array that you're making based on whatever logic you put inside this filter function definition that you're passing as an argument.
In practice, one of the more common ways of dealing with arrays when it comes to building web applications is the storage of objects within an array. So here there's an example of an array bounded by the square brackets. The elements within the array are each JavaScript objects. So each object has certain properties, fields, ID, title, price, description, and that's shared by all of them. If you wanted to loop through an array like this, you could use the array forEach function. Every one of those objects would be automatically passed into this product variable. And we would then do something with the information in each product, in this case, just logging it to the command